Pointers and allocation. When a function parameters pass by value, everything in Go is passed by value. The function always get a copy of the things being passed, as if there were an assignment statement assigning the value to the parameter. For instance, copying a pointer value makes a copy of the pointer, not the data it points to. Map and slice values behave like pointers. They are descriptors that contains pointers to the underlying map or slice data. Copying a map or slice value doesn't copy the value data it points to. Copying an interface value makes a copy of the things stored in the interface value. If the interface value holds a struct, copying the interface value makes a copy of the struct. Should we define methods on values or methods on pointers? When defining a method on a type, the receiver behaves exactly as if it were an argument to the method. Define the method on a pointer type if you need the method to modify the data the receiver points to. Otherwise, it is often cleaner to define the method on a value type. What's the difference between new and make? In short, new allocates memory, make initialize the slice. Map and channel types. The sizes of int and uint are implementation specific, but the same as each other on a given platform. The 64-bit Go compilers uses a 32-bit representation for int. Code that relies on a particular size of value should use an explicitly sized type, like int64. On the other hand, floating point scalars and complex numbers are always sized. Float 32, complex 64. Because programmers should be aware of precision when using floating point numbers, the default size of a floating point constant is float 64. How do I know whether a variable is allocated on the heap or on the stack? From a correctness standpoint, you don't need to know. Each variable in Go exists as long as there are references to it. The storage location chosen by the implementation is irrelevant to the semantics of the language. The storage location does have an effect on writing efficient programs. When possible, the Go compilers will allocate variables that are local to a function in the function stack frame. However, if the compiler cannot prove that the variable is not referenced after function returns, the compiler must allocate the variable on the garbage collected heap to avoid dangling pointer errors. Functions and methods. The method set of any other name type T consists of all methods with receiver type T. The method set of the corresponding pointer type T is the set of all methods with receiver pointer T or T. If an interface value contains a pointer T, a method call can obtain a value by referencing the pointer. But if an interface value contains a value T, there is no useful way for a method call to obtain a pointer. Packages and testing. How do I create a multiple package? Put all the source files for a package in a directory by themselves. Source files can refer to items from different files at will. There is no need for forward declaration or a header file. Other than being split into multiple files, the package will compile and test just like a single file package. Implementation in Go. What compiler technology is used to build the compilers? GCC Go has a C++ front end with a recursive descent parser coupled to the standard GCC backend. GC is written in C using Yak and Bison for the parser. Although it's a new program, it fits in the Plan 9C compiler suite and uses a variant of the Plan 9 loader to generate ELF binaries. How is the runtime support implemented? Again, due to bootstrapping issues, the runtime code is mostly in C with a tiny bit of assembler, although Go is capable of implementing most of it now. How are libraries documented? That is a program, GoDoc, written in Go that extracts package documentation from the source code. It can be used on the command line or on the web.
This is the whole Go package tree. There's about 120,000 lines of source code, and we're going to build the whole thing. And the package tree includes flags and regular expressions in the math library and formatting library, an RPC package, a full parser for the Go language, and many other packages. And there, it built in under 10 seconds, and that's just running on one machine, my laptop. When builds are that fast, I can get a lot done in a day.